Now we are going to consider how to solve for the intersection between two lines when they are given in general form. So let me write down a couple of equations of lines. Let me write down 3x plus 2y equals 4 and 2x minus 4y equals 5. We won't try to plot these now because that would be a little time consuming. We could find the x and y intercepts quickly by subbing zeros in for x and y, but that won't be necessary right now. So we have a couple of choices. We could solve for, in fact, we have 4 choices. We could solve for x in the first equation and then substitute into, let's call this equation 1, and then substitute that result into equation 2. We could solve for y in equation 1 and substitute that into equation 2. We could solve for x in equation 2 and substitute into equation 1, or we could solve for y in equation 2 and substitute into equation 1. For the sake of this video, I'm going to choose to solve for x in equation 2 and then substitute into equation 1. But any of the 4 options would be pretty much equally as good in this particular case. So, in order to solve for x in equation 2, I'm going to add 4y to both sides of the equation. When I do that, I'm left with 2x is equal to 4y plus 5. In order to solve for x, I need to divide both sides by 2. That would leave that x is equal to 2y plus 5/2. Now that I have solved for x in terms of y, I can substitute into equation 1. When I do that, I can look at equation 1 and I take 3, and instead of writing x, I write what x is in terms of y. And that is the critical step. We started with equation 1 having x and y as variables, and equation 2 having x and y as variables. So we had 2 equations with 2 unknowns. Now we need to, by substituting in for x, we have one equation, we have a new equation, and this new equation has one variable left. It has only y left. So at this point, we can use algebraic techniques. We can distribute the 3 on the left-hand side, and we can get that 6y plus 15/2 plus 2y is equal to 4. We can combine like terms on the left-hand side and say that 8y plus 15/2 is equal to 4. I like to get rid of fractions, so I will multiply both sides by 2 and get that 16y plus 15 must equal 8. And now we can subtract 15 from both sides. And we can say that 16y is equal to negative 7. So y is equal to negative 7 over 16. Now that we know what y is, we can substitute back. So notice we substituted x in terms of y into equation 1, and now we substitute back into equation 2 in order to complete our task. But we don't substitute into equation 2. We substitute into the simplified version where we had solved for x, and this will allow us to quickly determine what x is when y is negative 7/16. So since the denominator is even, I will make my first term negative 7/8. And in order to have the same denominator of 8, I will multiply numerator and denominator of the second term by 4. So I get plus 28. So x should be 13/8. So where do the lines intersect? They intersect at 13/8, comma, negative 7/16. Now, a couple of things to look out for. this is how to solve this problem. We can avoid solving a problem altogether if some of the following things were to happen. Okay, if I notice that this was 3x plus 2y equals 4, and then I had something like 6x plus 4y equals 7 as my second equation. Notice in both cases we have a positive relationship for all of the coefficients. Okay, so it's an implied positive 3 and positive 6 in front of the x's, and a positive 2 and positive 4 in front of the y's. And also, if we look at the x to y ratio, it is 3 to 2 in the first equation, and it is 6 to 4 in the second, which is equal to a 3 to 2 ratio. So if we took the time to plot these two lines, we would actually see that what we have are parallel lines. So when you have equations with parallel lines, obviously they can't intersect, and there will be no solution that can satisfy both equations at the same time.